What if you could run a model that competes with the best closed source AI in the world, but on your own infrastructure, with your own data, and under your own terms? Because that's what NVIDIA just made possible, and that's exactly the kind of thing we're here to talk about. Welcome to the Private AI Lab, the podcast where we experiment, explore, and debate the future of AI behind the firewall. I'm your host, Johan. Now, if you've listened before, you know we usually have a guest in the lab. But I'm trying something new. No guest today, just me, a fresh NVIDIA announcement, and one very opinionated Dutch take on what it means for private AI. A thorough breakdown, no filter. Let's see how this lands. So NVIDIA just announced Nemotron 3 Ultra at ComputeEx 2026. The full name is Nemotron 3 Ultra 550B A55B. Let me unpack those numbers because they're actually the point. 550 billion parameters in total. That's a massive model. But here's the thing. Only 55 billion are active at any given time. This is called a mixture of experts architecture, or MOE. Think of it as a company with 550 employees, but only 55 most relevant specialists show up for each meeting. Everyone else stays at home. So the work gets done at the highest level, but you're not paying for 550 people's coffee. The result, a model that thinks like a 550 billion parameter frontier model, but runs like something far smaller and faster. And the most important part, open weights. Most permissive license, free, run it yourself. That's the whole point of this podcast. So NVIDIA has been building the Nemotron family for years now. There's the Nano, optimized for efficiency on subtasks, a Super, built for multi-agent reasoning, and now the Ultra for what they call frontier reasoning and orchestration. Orchestration is the key word here. This model isn't designed to answer questions. It's designed to manage, to take a complex multi-step task, break it down, delegate subtasks to other models or tools, and synthesize a final result. That's a fundamentally different job than answering what's the capital of France. And this is what I'd call agent brain. And the fact that it's now open, that matters. Okay, benchmarks, I know. Every model announcement comes with a slide that shows the new model winning at everything. Usually you squint a bit and move on. But let me walk through these because I think they're worth taking seriously. NVIDIA compared Nemotron 3 Ultra against three competitors. GLM 5.1 from Sifu AI, which has 744 billion parameters. Kimi K 2.6 from Moonshot AI, a full 1 trillion parameter model. Qwen 3.5 from Alibaba, 397 billion parameters. So we're talking about models that are bigger, sometimes much bigger. Kimi is almost twice the size, and Nemotron still wins on most of the tasks that actually matter for enterprise AI work. Looking at instruction following, 82%, best in class. For agents, this is critical. If the model can't reliably follow complex instructions, the whole system falls apart. Looking at long context, 95%, best by a large margin. And here's the kicker. GLM and Kimi couldn't even run this benchmark. They max out at 256,000 tokens. Nemotron 3 Ultra handles 1 million tokens. That's roughly 750,000 words of context. You could feed in an entire technical code base and ask it to reason about specific design decisions. That's not a gimmick. That's real capability. And looking at agent productivity, 91%. It's tied with Kimi. Professional work tasks, 56%, also tied with Kimi. Whereas weaker is, for instance, with coding. So it's 54% on TerminalBench 2.0 versus Kimi's 67%. So if your primary use case is pure code generation, Kimi K might edge it. For orchestration, reasoning, and document work, Nemotron is the better call. Honest assessment, this is genuinely competitive. Not competitive for an open model, but competitive full stop. So here's when it gets interesting. NVIDIA's data show Nemotron 3 Ultra running at around 300 output tokens per second. The competition, roughly between 50 and 60 tokens a second. That's a roughly 5x speed advantage. On a chart plotting intelligence versus output speed, Nemotron sits in what they call the most attractive quadrant, meaning fast and smart, not one or the other. Looking at cost, based on the SWE-bench, coding tests on CoreWeave and Deep Infra, Nemotron completes tasks around $800. Kimi K2 at the same completion rate costs around $1,300 and GLM costs around $1,700. That's up to 30% cheaper than the nearest open alternative. And that's before you factor in running it yourself on your own hardware, no per token bill, no API call every time your agent takes a step, autonomous workflows. That cost difference compounds up. So why is it actually good? Let me nerd out for a second on what actually makes this model perform the way it does. So it has a multi-teacher on-policy distillation. Most models learn from one teacher. Nemotron 3 Ultra learned from multiple frontier models simultaneously during real inference, not from static data after the fact. The result is a model that picked up diverse reasoning strategies from the best models in the world. It's like getting tutored by 5 different experts instead of one, and they're all watching how you actually solve the problem in real time. Let's look at the unified NVFP4 checkpoint. This is about precision. The model uses a quantized format called NVFP4 that reduces the memory footprint without tanking quality. And critically, it's the single checkpoint that works on both Blackwell, so the new B200 GPUs, and Hopper, the H100s that most people are actually running today. You don't need to choose a version based on your hardware. One model fully optimized for both. It's also post-trained for agent harnesses. This is a bit that matters most for what I care about. The model wasn't just trained to produce good text, it was specifically fine-tuned for multi-turn, multi-tool agent workflows using NVIDIA's own open data set and environments. It knows how to use tools reliably, it knows how to maintain context across a long conversation. That's not trivial and it's not common. The next topic is multi-token prediction with the 1 million context. Predicting multiple tokens at once is what drives the speed advantage. Combined with a 1 million token context window, which is enabled by the MOE architecture, you get a model that's fast, capable of deep reasoning, and doesn't lose the thread on long tasks. And obviously, it has full NeMoClaw support. So a model without infrastructure is just a file. NVIDIA knows this, and that's why they're launching NeMoClaw alongside of it. NemoClaw is not a model, it's a blueprint for building autonomous agents. Think of it as the scaffolding that turns Nemotron 3 Ultra into an operating system. It installs OpenShell, a secure runtime for safer agent operations. It supports open agent harness, including Hermes agent, and it's designed to connect Nemotron to real tools, APIs, file systems, search, externals, you name it. The idea is simple. You take Nemotron 3 Ultra as the orchestration brain, you wrap it with NemoClaw, and you have a fully operational, long-running autonomous agent running on your own infrastructure, talking to your tools and handling your data. That's exactly the private AI story. Not a demo, not a managed service you have to trust, your own agent, your own control. So I got early access to the Nemotron 3 Ultra endpoint, and I immediately did what any reasonable Dutch AI researcher would do. I pointed it at soccer, or what we call football, at this side of the pond. Here's what I asked Jarvis, my NemoClaw agent, to do. Can you do a deep research task on predicting the chances of the Netherlands winning the World Cup Soccer 2026 in the US, Canada, and Mexico? Please research every match, all potential finals, and predict the Dutch winning the cup. Now here's where it gets interesting. It didn't just run this once, it ran it twice, with 2 different agents on the same task at the same time. One agent I'm calling Bruce Banner, that's my local setup running Qwen 3.535B with Alama on my own hardware. And the other one is Tony Stark, the Nemotron 3 Ultra endpoint. Both agents went to work, 8 web searches each. multiple fetches across betting markets data, Monte Carlo simulation platforms, FIFA cross-referencing, reasoning, building a structured output. Now, looking at the output of Bruce Banner, Qwen running locally, it came back in about 3.5 minutes. Solid report, good structure, and the main finding is the Netherlands add 5 to 5.5% win probability, 8th favorite going into the tournament. Looking at Tony Stark, the Nemotron 3 Ultra, it came back with a 5.8%, slightly more bullish. And the analysis was more granular. It mapped out two completely different knockout paths depending on whether we finish first or second in Group F. And this is the part I find genuinely fascinating. If we finish first in Group F, which, both models put around 68% probability, our likely R32, so round 32 opponent is Morocco. It's manageable. We avoid Brazil until a potential final, and that's the path where the math says we have a real shot. If we finish second, we get Brazil in the round of 32. Tony Stark put the win probability for that game at 25%, which honestly feels optimistic. So, finish first or go home early. That's the tournament in one sentence. And you expect from a deep research task done probably. De Jong's fitness is the single biggest risk factor. Losing him drops out probability from 5.8% to about 4.5%. Cody Gakpo is the attacking key, and Xavi Simons is out entirely due to an ACL problem. And then there's what the model called, with no prompting from me, the Dutch curse. 3 World Cups finals, 0 wins. Wembley in 74, Buenos Aires in 78, and Joburg in 2010. The model has to read the history. What I actually care about here isn't the win probability, it's what this task demonstrates. 2 agents, same prompt, real research, multiple sources, structured probability reasoning across 7 rounds of a 48-team tournament. This is not a chatbot answering a question. This is an agent doing exactly analytical work. And comparing Bruce Banner to Tony Stark side by side, that's going to be its dedicated own episode. The Orange Army, we're counting on you. The models have done their work. So here's the thing most people will miss about this announcement. It's not a good open source model. This is NVIDIA putting a frontier clause reasoning model, the kind of model that was until recently only available through closed APIs from OpenAI or Anthropic, with a permissive license, with training data transparency, with the infrastructure blueprint to actually run it. For everyone working on private AI, sovereign AI, self-hosted AI, AI that runs where you decide it runs, this is a milestone. The gap between open and best just got a lot smaller. Nemotron 3 Ultra, 550 billion parameters, 55 billion active, 1 million token context, 5x faster inference, up to 30% cheaper to run, open weights, runs on H100 today and B200 tomorrow. And somewhere in my home lab, Jarvis is still thinking about Dutch soccer. Thanks for tuning in to the Private AI Lab. If you want to go deeper, links to the model weights on Hugging Face, the NemoClaw blueprint, and all the benchmarks are in the show notes. And for more experiments and insights, head over to Johan.ml. Don't forget to subscribe on Spotify, Apple Podcasts, or YouTube, or follow the Private AI Lab newsletter on LinkedIn. Experiment complete. Until the next one, stay curious.
Private AI Lab.